Ladies and gentlemen, the strides in healthcare over the last decade have been extraordinary and show no signs of slowing down. To discuss the changes that the next 100 years are likely to bring, please welcome to the stage Renee Wegryzn, co-founder and Chief Innovative Officer at Stealth AIxBio, John Cumbers, founder of SynBioBeta, Bigyan Bista, Senior Vice President and Head of Business Strategy and Development at Enveda, Karina, Barao, Associate Director for Governance at SCSP, moderate the discussion.
Good afternoon, everyone. I'm so excited to welcome you to the second SCSP AI Plus Expo. My name is Karina Barao, and I'm an Associate Director for Governance at SCSP. I have a deep passion for what we are going to be talking about for the next 30 minutes, which is the future of health. I'm happy to be joined by three speakers who each sit and have sat in various roles across our health innovation ecosystem. We have Renee Wegryzn, the first director of ARPA-H and co-founder and chief innovation officer at Stealth AIxBio. Next is John Cumbers of SynBioBeta, who's been building and convening the synthetic biology community for over 13 years. And last but not least, we have Bigyan Bista, who is leading business strategy at a very intriguing startup focused on translating nature's chemistry. These experts are going to paint a picture for us of what they think the world will look like in 21-25 for health. But to talk about the future, I'd like to level set and briefly touch on the present, the past, and how far we've come. So first, I'd like to ask and pose this to Renee. How far have we come in the health field, and what trends in health are you seeing on the ground today?
Thanks very much for having me here today. I love that question, and when we did a little bit of the pre-work, I looked to see where were we 100 years ago, right? If we're looking 100 years in the future, how can we really think about the trajectory that we've been on? 100 years ago, there were no antibiotics. The life expectancy was about 58 years old. We had all of our babies at home, and we paid cash for healthcare. There was no health insurance. And so really thinking about how far we've come, that's a really incredible way to think about that trajectory, that we created antibiotics, but yet we face these new challenges that we have antibiotic resistance. We have come so far in bringing health to communities out where we had healthcare in the home, and now we have an aggregate of these centers of excellence where we can have best-in-class surgeries, but we're creating new disparities where now if you live in a rural setting 300 miles away from those centers, you can't access that care. So I think it's a really intriguing paradigm that we have these innovations, but yet there's so much of an opportunity to continue to grow over the next 100 years.
John, over to you. What are you seeing on the ground?
Well, just to not be boring and be a little bit controversial, I'm going to disagree. And I just want us to go back 10 years and look at the decrease in life expectancy, the opioid epidemic, the obesity epidemic, the mental health crisis. We've gone nowhere in healthcare if you take the framework a little bit shorter.
Yeah, that's fair.
Bigyan, over to you.
Sure, yeah. So maybe because I originally come from Nepal, I will just give you one anecdote. I left Nepal for US back in 2003. Back then, life expectancy in Nepal was 58. Today, it's 73, right? In just a matter of 20 years. A lot of that has to do with really early intervention, especially for infant mortality, but at the same time, other interventions across the spectrum. So I think you will find what you want to find as you look around the world, but we certainly have come a long way. And I think we'll discuss further like all the interesting trends, health tech, where we are going is absolutely interesting and fascinating. Yeah.
Amazing. Thank you for that. And what are you guys seeing on the ground now within your respective fields? You know, we have so much innovation being thrown at us every single day. What excites you the most about what's happening now? Over to you, Renee.
Yeah, let me start. So I was lucky in my role at ARPA-H that we were able to look across the entire health ecosystem to find those little pockets of innovation to get really excited about. And I don't have any favorite programs, but there's a few that are notable. One was a program focused on whole eye transplantation. And so this is really looking at the challenge of being able to preserve an eye, reconnect the optic nerve, and then be able to understand those signals to restore sight. These are the types of innovations that are really on the cusp of being real. You can imagine the plan to get us there now that technology has emerged to that level. The other that I'll mention, I think, is in the stem cell domain, we're really starting to harness the ability to more reliably program stem cells and start to have some restorative function. One of the efforts that we pursued was looking at joint replacement, and instead of having a surgery where you have to replace a hip or knee, it's actually a needle-based injection to regrow your joints. So those are the types of futures that I would be excited to live in, and the technologies I really want to pursue.
I'm most excited about the field of synthetic biology broadly. The vision for synthetic biology is that we can create cells and gene circuits that are as predictable as any other kind of engineering discipline. If you look at mature engineering disciplines like computer engineering or software engineering or civil engineering or structural engineering, these are all mature disciplines whereby we have processes to engineer complex systems and produce reliable, repeatable, robust engineering outcomes. Look at the cell now, and we, after 20 years of trying to do this in synthetic biology, we have not yet been able to reliably, robustly, repeatably, at a cost that is achievable, actually take cost out of it. We just can't do it. We can't yet engineer biology as if it were a computer system, as if it were a software system. So I think that we are making progress towards doing that, but it still remains the most interesting thing on the horizon. And in particular, the impact of these AI tools and the impact that AI is going to have on being able to robustly, reliably engineer biology, I think is the most exciting thing.
So the fundamental problem in pharma industry and especially drug development is that things that work in the lab don't work in people, right? It's really that simple. A lot of that has to do with how complicated biology itself is. To give you one example, even after years of investment and billions having poured into drug development, only 1 out of 10 candidates will reach FDA approval, right? That's the best we can do with the best scientific advances that we have made today. To give you one example, at Enveda, what we are trying to do is we are actually turning the tables on this number by relying on 2 things. So one, evolutionary intelligence, and second, human wisdom. So what do I mean by that? Billions of years of evolution have created such a tremendous diversity of chemistry in, on, and around us that we can explore. And we have been, and that's the second part, which is collective human wisdom. For hundreds of thousands of years, cultures around the globe have always tapped into nature to treat different ailments, right? So that gives you kind of a prevalence of compounds with real world usage already. It's very hard to go after them systematically, and yeah, it's very difficult. So that has been a bottleneck, and that's what we have tried to solve using AI. So we now employ cutting-edge AI ML tools, high-throughput robotics, so that we can go after nature's chemistry in a very systemic fashion. And we have already done that really well. In just 4.5 years since the seed round, we now have 10 candidates, actually 12 development candidates in our pipeline. One of them is already in the clinic. So we have done all of this at a fraction of cost and speed and at scale. And we aren't the only ones doing it, right? So there are slowly more companies emerging, and that's the excitement, right? So the R&D productivity is what gets me super excited about our field.
Thank you for that. So this conversation focuses on where emerging health tech is now, but also what innovations are on the horizon and what we predict the health world to look like. So some of you have already jumped the gun, but since we are at the AI Plus Expo, it's very necessary to ask, how is AI interacting with the technologies you're working with? What are the use cases? What are the applications that this audience should know about?
I think one of the ones that is maybe overlooked, but is something I'm really excited about, is AI at the interface of cyber for health. And so it turns out that our healthcare system is the most attacked surface out there, anywhere, for cyber, but yet we have zero workforce to address this, where it's, if you are in the healthcare domain, you know that we don't have the capabilities that we have at Fort Meade and beyond at NSA. So, we're not going to build that workforce to be able to keep up with that threat in healthcare. And so that really brings into play the opportunity to have autonomous AI be able to detect vulnerabilities and patch those vulnerabilities proactively. And if we don't really build those systems today, I think we're going to be significantly at risk. And so I've been very excited to see portfolios of investments start to emerge, everything from protecting devices to entire healthcare systems, to prepare for that future that will be AI native, AI enabled, but also AI protected.
One of the technologies that is right on the cusp is regenerative medicine, and in particular, cell reprogramming. And one of the examples that I want to give is an entrepreneur called Jean Loring. She's at Scripps Institute in San Diego, and she's the founder of a company called Aspen Neuroscience. And I called up a friend of mine recently to ground one of my ideas that I was brainstorming with somebody about, which was this idea of brain replacement, that you can inject neurons into your brain and slowly replace your brain bit by bit and prevent the brain from aging. And I said, I know this is science fiction, but I want to chat with you about it. And actually, Renee, one of her former program managers at ARPA-H, John Hibbert, wrote a book all about this called The Replacement Theory of Aging. And my friend said, that's not science fiction. My stepmother has early onset Parkinson's disease and is currently being treated at Harvard Medical School, one of the hospitals affiliated with Harvard. And she recently went in, had a biopsy of her skin cells taken, converted them into her own neuronal cells, and then over the last 6 months has had her own neuronal cells injected into her brain at 5 particular points to replace the neurons that are being degraded by the Parkinson's disease. Just last month, she got a readout from the results, which were fantastic: improved cognitive function, improved ability to move. And this is all because of Jean Loring's company called Aspen Neuroscience. So this stuff is right here on the cusp. It's already being used for clinical trials of Parkinson's disease. And I think it's super exciting, just this idea of being able to replace any cell in the body with any other cell that you want, with any new kind of cell. And the impact that AI is having on this with these data sets for reprogramming cells is going to be huge.
So I will give maybe one example of Enveda and then some other trends that I'm seeing. So at Enveda, AI is the fundamental pillar, right? So what we have done is we have trained machines to interpret chemistry. You can think of Enveda platform as AlphaFold for chemistry. So like if you have heard about AlphaFold, there you can basically type in a sequence of amino acids and it will spit out putative structure, right, of that protein, and then you can do a lot of things with that structure. In our case, we train algorithms that can interpret mass spectrometry. It's a technology that allows identity of compounds, right, in any given mixture of unknowns. And we train more than 1.2 billion of these MS2 spectra. That kind of scale, it's only achievable by AI, right? Like that's just not for humans. So now we can interpret those MS2 signals as chemical structures. And we combine that with function, right? So that's how simultaneously we can answer 2 questions what are the molecules and what do they do without doing isolation, purification, one compound at a time, which is what has held the industry so far behind. So in terms of other healthcare trends, plenty, right? And what keeps me really excited is the common feature that I see across them is a move towards proactive care from reactive. Exactly what John just said, right? Like early onset of Parkinson's, not when it's like too advanced that any intervention will make any meaningful difference. So one example would be AI-powered precision medicine and diagnostics, so even risk stratification, AI-powered drug design that many companies are pursuing. Then there's also wearable, like sensors that go beyond your wrist, right? Now there are all kinds of sensors continuously monitoring what's going on inside you. But it's really the convergence of biotech and tech. That is what really excites me.
So next I'd like to ask, what technologies just beyond our grasp today are you most excited about when it comes to health? And if you could expand on that by talking about what are a few things that we need to get right in order for those technologies and those innovations to be realized? Are there any bottlenecks? Are there certain pieces of the puzzle that we need to solve in order to have these breakthroughs, you know, get into people's hands and really truly transform people's lives and their health?
Yeah, I want to share like just a little bit of a journey from my time as a DARPA program manager, where we invested in tech bio and really making, you know, high resource, really focused efforts that would fail when they would leave. Many of them succeeded, but the ones that failed, it was because we would not be able to line up follow-on funding. So when we stood up ARPA-H, I was like, we have to make sure that we have investors that are close and helping us de-risk not just the technology, but parts of the investment, whether it's regulatory or policy or whatever that might be. So we've successfully done that, and now I've realized that there's actually one extra piece that we're missing, and it's a problem I've become obsessed with, which is what the last piece of translation besides the funds to get things out of a lab and into the real world is capturing some of that tacit knowledge. So if you're an expert scientist, you do a lot of the things in the lab without writing them down because you just know how to do it because you've done science for 20 years. You can apprentice when I want to teach John how to do something, it's easy for me to share that with him, but we might not write that down. And so when I leave the lab or John leaves the lab, that knowledge goes with us. And so that is one of the reasons that that tech transfer fails, and that getting knowledge in a distributed way, if you have a technology to license, fails over and over. And so I do think that this is an area that is within reach with reinforcement learning and some of the inference models that are being developed that we can capture through LLMs and protocols, but also computer vision to see what's happening, and even verbal cues to understand what is actually happening. What's that magic that's part of an experiment that then we can then reliably and predictably transfer that technology. I think that will help us address the emerging bottleneck, which is, you know, the explosion of AI drug discovery. There's billions of designs we can look at top of the funnel, but all the rest of the bottlenecks are still the same. And so how are we really systematically addressing that to accelerate getting tech off the bench into patients' hands?
I want to talk about the bottlenecks in synthetic biology specifically. I mentioned about the need to engineer biological systems. SynBioBeta is mostly known for a trade show that we put on in the Bay Area once a year. And in our expo hall, we have design, build, and test laid out for biological engineering. On the design side, there are companies designing biological sequencing. On the build side, there are DNA synthesis companies that are synthesizing genes and genomes. And on the test side, there are these automation companies that are making it easy to test whatever circuit you've designed to engineer your biological system. What I think we're on the cusp of is the speeding up of that design, build, and test cycle so that we can program cells and get the readout from the cell that you've programmed within what I hope will be hours and eventually will be minutes and maybe at some point will be seconds. And right now, it's about 2 weeks. The cycle time of design, building, and testing of a cell to do something, the fastest we can do it is about 2 weeks. Imagine if I went over to Microsoft over there or OpenAI here or Palantir and said, hey, you want to learn how to program biology? Just load it up and then come back in 2 weeks' time and see what the result is, right? No engineer would enjoy doing that, and that's what every biological engineer that's doing strain engineering or biological design is having to put up with right now. So I think we're on the cusp of that flywheel for synthetic biology to really go fast and get it down to a few days and then eventually to minutes and seconds. And once we can do that, wow, then what can we engineer those cells to do? Anything. And nothing is beyond our imagination at that point.
Certainly, and what can we not do now that we have that figured out? What do you think?
So prior to joining Enveda, I was a biotech investor as well, and have come across maybe 800 plus biotech pitches, approaching them even with the healthiest of skepticism, because there does tend to be a lot of outlandish claims that get made in biotech pitches. There is a lot to be excited about, right? So some examples, piggybacking on John's comment about programmable cells, there are now companies already working on in vivo CAR T, right? So imagine, right, like getting cells inside your own body to do the things that you want them to do. There are bispecific antibody companies that have logic gates built in them, which means they will only be active in the context of disease and not in the case of healthy cells. This is very important from a toxicity standpoint, right? So there are some early signs. It's still ways to go, but they will make those breakthroughs, and we might be maybe 10 years away from seeing them become reality. The other ones, brain-computer interface. You probably have read like some news articles where BCI has led to regaining of like some sensory functions in certain patients. We can only expect that to improve with time. In vivo drug factories, right? Like imagine if you are a diabetic patient and there's an implant in you of cells that will make insulin on demand. Again, there are early signs that maybe this will become possible. It will obviously need to go through like your own body's immune system not attacking those cells, but those are being made, right? So those are some of the breakthroughs. Organs on chip, very exciting. So if you have followed the news, now FDA is trying to replace animal testing by utilizing organs on chip to study toxicity. That's a really good test case, because this might lead us to places where this becomes pretty important even for human conditions. And lastly, what gets me really excited, having sat through several sessions at SCSP AIxBio, is agentic AI. Like imagine having an agent as your personal health coach that does not get tired, that just learns from you as you go. And that's so coach for life, right? So all the way from interventions to behavioral nudges, all of that does seem like rather within grasp, right? Like if not tomorrow, but not in the not too distant future.
All right, then, the moment you've all been waiting for. 100 years from now will be 2125. So based on what you all have shared with us here today, if you fast forward 100 years, what do you think the health world will really look like then in 2125? And if anybody would like to touch on, you know, the role of our competitors, for example, perhaps China, where we think they may be as well in 2125, please share that as well. Go ahead, Renee.
Yeah, I feel like I could talk about this topic for 3 days, which would be a lot of fun, but a couple of highlights, and I really want to start with the competitiveness angle. You know, what anybody on this stage talks about now is really going to be a function of whether or not we lead in the current paradigm that we have today. We lead where it's US-led science and engineering, or on the funding side, how are we going to move forward to a future where clearly we do not have a resilient, robust funding ecosystem. It's not going to be federal only going forward. That's very obvious. What does that look like? So 100 years from now, I would love to have a robust and resilient funding ecosystem that is self-sustaining, that we can continue to innovate going forward. Should also say that given the 100-year timeline, I don't know that we have all the answers of how we're going to get there, but these are the futures that we must bring forward. I know there's a lot of excitement about aging, so I won't go there. I think maybe some of my panelists will touch on that. But interoception is something that I've been really intrigued by. We've seen the emergence of wearables as a way to sort of, on the outside of your body, be able to measure what's happening inside. What about skin and in? What does that look like in 50 years from now, that our body gives us a sensation if it detects a circulating tumor cell in a very early stage, that we'll know that that's there. Terraforming the human body is another area. I do think that we will start to move towards enhancements as a requirement to changes on our planet that we will need to be resistant to, whether it's heat, whether it's a different atmosphere, whether we do space travel. And that will be an area that we explore and need to learn from. And then last but not least, this is I just really deeply believe that we have to stop talking about health for women as something that is separate and different from men's health. We are all human, and it should be one spectrum and one understanding of we are each an individual that we need to create a healthcare solution for, and it's not something that is fundamentally different.
Just to touch on the human augmentation, did you say terraforming the human body? I love it. I read this week that in Las Vegas is the first Olympics where the athletes can take whatever drugs they want to take to enhance their competitiveness.
Which Olympics is this?
It's got a special name, but
Okay.
it's an Olympics for people who want to be able to take performance-enhancing drugs to enhance their performance. So I think it's really interesting to see people pushing the limits of the human body. If I think about the next 100 years, I am 100% sure that humans are going to be living as long as they want to live. And I think it's okay to talk about that. I think it's okay to do that. I think it's a celebration of human ingenuity, what we're going to be able to do with human longevity. I think in 100 years, we're going to fully understand biology. And I think the tool that's going to enable that is AI. And when we have a complete understanding of biology, I think we're going to have a complete understanding of how to engineer biology, which is the vision of synthetic biology. I mean, we're 100 years out, I got to say it. We got a full understanding of the brain and of human consciousness as well. I really think that the combination of all of these technologies and AI to be able to put this microscope of data collection on any problem that we point, and biology is a big problem that we should point to. And I think with the understanding of the brain and consciousness comes our understanding of mental health and substance abuse and addiction. The question about China is a really thrilling question. It's a frightening question in terms of Eric Schmidt, if any of you were at Eric's talk earlier, I see a few of you were, he talked about this exponential increase, this arms race for defense, and I think we'll see the same arms race in biology. And so I'm not sure where that leads in biology, but China is investing billions of dollars. The National Security Commission on Emerging Biotech has a panel tomorrow particularly on this. I think it's at 12:30 over in room 200 over there. So I think that's just fascinating. But I don't know what the outcome's going to be in terms of who wins the biology race between America and China in the next 100 years.
So yeah, as I think about the next 100 years of health, I will say two things with pretty decent conviction. So one, AI is not going to cure all diseases in the next 10 years, right? Or definitely not even 50. We have to approach biology with a lot of humility, is my view as a biologist. The second, enabling tools and technologies. I mean, all of them are getting so enhanced by AI that the next 100 years, we are going to see dramatic leaps compared to the last 100 years. So what I predict is a total shift from sick care to healthcare. Because right now what we have is sick care. We are deploying interventions when it's already too late, and that's why they are so pricey. The second one, all enabling technologies will get so seamlessly integrated into our lives that it will seem no different than breathing, right? It'll just be part of us. So all of that should allow us to focus on kind of three pillars: proactive, personalized, and preventative, right? So that's where I think the next 100 years will take us. Imagine, right, like all changes in your physiology being assessed in real time, and there's a feedback loop that feeds into maybe, as I discussed earlier, some in vivo drug factory, right? It just makes what it needs to make to fix you. Homeostasis, like on the go, right? Like none of those are outside the realm of possibility, given the timeline that we are talking about, which is 100 years. So I would say the last, kind of disease prevention, longevity, and human enhancement. I think those will be the key areas. I wouldn't be surprised if a significant percentage of humans on Earth will be walking around with some biomechanical insert in them in one form or another. It's tantalizing. It's so exciting. So that's where I will end my comment.
Ladies and gentlemen, Renee Wegryzn, John Cumbers, and Bigyan Bista, thank you so much for joining us today for this session.